how does gradient descent work in machine learning? Imagine trying to find the lowest point in a hilly landscape while blindfolded. You take small steps downhill, checking which way is steepest. That's similar to how gradient descent works in machine learning. In machine learning, models make predictions based on parameters like weights. These parameters need to be fine-tuned so the model predicts as accurately as possible. The difference between the model's predictions and the real data is measured by a loss function, which tells us how wrong the model is. The goal is to make this loss as small as possible. Gradient descent helps us do that by calculating the gradient, which is like a slope or direction of steepest increase of the loss. Think of it as a compass pointing uphill. Since we want to go downhill, the algorithm moves the parameters in the opposite direction of this gradient. The size of each step is controlled by a value called the learning rate. If the learning rate is too big, the steps might overshoot the minimum. If it's too small, the process takes longer. The process starts with initial guesses for the parameters, often random. Then, in each cycle, the algorithm calculates the gradient at the current parameters. It then updates the parameters by subtracting the product of the learning rate and the gradient. This process repeats many times, gradually moving closer to the minimum of the loss function. There are different ways to perform gradient descent. One method uses the entire dataset to compute the gradient each time. This is called batch gradient descent. It's very stable but can be slow with large datasets. Another method, stochastic gradient descent, updates the parameters using just one data point at a time. It's faster but noisier. The third method, mini-batch gradient descent, strikes a balance by using small groups of data points, making it both faster and more stable. In the world of emerging technologies and artificial intelligence, gradient descent is essential. It powers many applications like image recognition, speech processing, and recommendation engines. Faster hardware like graphics processing units and specialized AI chips have sped up these calculations, making training deep neural networks quicker. Researchers are also working on improving gradient descent with techniques like adaptive learning rates and momentum. These help the algorithm converge faster and avoid getting stuck in local minima. So, in simple terms, gradient descent is a way for machine learning models to learn from data by taking small, calculated steps downhill in the error landscape. It's a core part of how artificial intelligence systems get smarter and more accurate over time.